So 2022 deferred paper 2, and we are on question 8D, part 2. An egg is large if it weighs between 63 grams and n grams. Now we just have to, I suppose, remember back to what our mean and our standard deviation was. So we'll just do our bell-shaped curve again. So our mean, sorry guys, just throwing out a cat here. I'm being attacked. Okay, so mean is 60, standard deviation is 15. Okay, so we have standard deviation. So for example, team are at 45, and we could keep going, of course, but just to have that as our frame. Okay, so 63 is somewhere in there, and n grams. Now we've no idea where n is. Okay, so let's just put it anywhere for the moment. You know, I don't know whether it's smaller than 75 or bigger, but I'm just putting it somewhere just to get the idea. So it says 23%. So that is 23%, or 0.23 if we were to write it as a probability. And that's for large. Okay, so work out the value for n. So they basically we want to know that what is the range for large eggs? That's our goal. So use the mean and standard deviation, find the answer. Okay, so what do we do? Right, well, let's start by thinking about if we were getting the probability from 63 down. So the first thing I need to do really, if I want to use my log tables, is I need to standardize the score. So how do I do that? So this is, I suppose, what we call the actual, and then we can use our standardized score in order to find the probability of that happening. So if you remember, it is x minus, so the actual number minus the mean over the standard deviation. So it's 16. Okay, so let's work that out first. 63 minus 60 all over 15. Okay, so that's giving me 0.2. Now, that's my 0.2 is my standardized score. And let's talk about why that makes sense. So just for a moment. So the very, very middle should be 0 in terms of our standardized score. So the very middle is supposed to be 0. So then when we go up one standard deviation, the standardized score is supposed to be 1. So it absolutely makes sense that that first orange line is 0.2. Because can you see that? Because it's a little way up from 0 and it's a good bit down from 1. So that orange line that we put in provision, you know, well, we know that the orange line is at around 63. We don't know, but I mean, it's only a sketch, but it does make absolute sense that it's 0.2. Now, if it is 0.2, our standardized score, I guess what we would really like would be to know what the standardized score is also of the other one. So let's say we were trying to do that. Well, unfortunately, I don't have a figure. So we'll just put in the n, this unknown figure, minus the mean, which is 60 all over 15. So I can still do that, but it doesn't give me an actual answer like I got on the left. And that's a pity, because if I was able to get an actual answer here like this one, all I would have to do is do the black circle minus the green circle. Because what I would be really saying is, if I can get the entire probability from the second orange line and then subtract that entire probability, subtract away the one from the first orange line, it will leave me with the section that I'm looking for, which is the 0.23. So what do we do? Well, maybe we do just put down our black circle minus our green circle. And that should be equal to 23%, which is 0.23. Now, what is this 0.2 in terms of probability? Because remember, the 0.23 is a probability, whereas 0.2 is a Z score. And as we're talking about it, 63 is actually the weight of the egg. So the 63 is the actual, that's something real, you know, that's the weight of the egg. The Z-score is really how far it is away from the mean. And then if I want to go from Z-scores to probabilities, well, then I need to go to my log tables. So right now, I can't do anything. I can't go to my log table yet regarding the black circle, but regarding the green one, I should be able to fill that in. So I'm going to get rid of my green circle because my goal here is to fill it in. So what I do is I go to my log table, page 36, and I figure out that 0.2 as a probability is 0.5793. Now, this is important. You can't have an equation where this bit is a probability and this bit is a Z-score. They're either all probabilities or all Z-scores. So that's very important. So we've another problem here in that this black circle would technically be a Z-score, but it's not a Z-score that actually goes in there. So I'm going to delete that for a second and I'm going to put a different color, because what actually needs to go in there is the probability of that Z-score. Okay, so where do I go from here? So I'll go over here to the side. So I'll just rewrite that actually for a moment. So the probability that's missing, 0.5.2, 0.23, add them. So that should give me my probability. Okay. So what is this probability? So it's might as well just throw it into the calculator, 0.5793 and adding on 0.23. So that's giving me 0.8093. Now, remember, that's a probability. So what I've discovered is the probability that matches up with that Z-score. That's what I've discovered. Now, because this is a probability, so let's just label that in case we get confused. Because this is a probability, when I look at my log table on page 36, I should be looking at the 4-digit numbers, as in the ones with 4 decimal places. I'm not looking at the bold print. So it's not a Z-score, it's a probability. So I need to look within the table at the 4 decimal place numbers to figure out, is there a 0.8093 in there? So on page 36 of my log tables, as I scan along and I have a look at all the probabilities, I find a 0.8078, I find a 0.88106, I find a 0.8133. Now, 0.8133 is quite far away. 0.8106 is the closest I can get. Okay, so if the I might just write that here actually in case you're looking back on this and you're wondering why the number changed. What I'm going to do here is I'm going to write down the closest actually have here in front, 06. Now that's, I mean, it's quite close, isn't it? So, you know, it's not going to be completely off. It's not ideal, but it's 13 away. Well, it's not even 13 away. It's 0.0013 away. Now, what I'm looking at there is still a probability. But now that I have a probability that is present in the table, I can reverse and go, well, what was the Z-score, you know, that matches that? So that's my probability. So what is the Z-score that matches that? So if I look to my table on page 36, I can see 0.88. So 0.88 is in fact the one that matches my closest available probability. Now we're on the last step, because now that I have the Z-score, you see, what we're doing here really is we have the weight of the egg, we have the Z-score, and then we have the probability. So what I've had to do here is I've had to work my way down through the question to find the probability, then bring that back to a Z-score, and now I have to bring it back to actually finding the weight of the egg, the N itself. So how do I do that? Well, I'll rewrite it. N minus 60 over 15 equals 0.88. So I'm just going to cross multiply, I guess. N minus 60 is equal to. So what's 0.88 times by 15? 13.2. And then my last step is to add on the 60. And that gives me 73.2. Now, are we asked to the nearest gram? So 73 grams. So finally, I have found out that what we're looking for is that this large egg is actually when the egg weighs between 63 grams, which is given in the question, and 73 grams. So now we've reached our final answer, and that's that done. The very last part of that, 19% of the farmer's eggs are extra large, 23% are large. Due to a fault with a sorting machine, all of the large and extra large eggs in one batch are mixed up at random and boxed together. So somebody's made a mistake, and instead of having large eggs and extra large eggs, they're all mixed in together. It is too expensive to remove all the eggs from their boxes and sort them again. So the farmer instead labels all these boxes as large. He has to label them, I suppose, the smaller size, because if you bought extra large eggs and some of them were only large, you'd be annoyed. So he's kind of playing it safe and he's labeling them all large. In such a box with 6 eggs, find the probability that at least 5, so that's an important kind of phrase, at least 5 of the eggs will be extra large. Give your answer correct to 3 decimal places. So if it's at least 5, would you agree it's 5 or more? Now, because there's only 6 eggs per packet, it's 5 or 6. So really what we're saying here is there's 2 options. Out of the 6 eggs, 5 of them are extra large, or out of the 6 eggs, all 6 of them are extra large. Careful here, because we're not talking about all the eggs. We're only talking fill in these probabilities. We have to be careful. So I can't just stick in, extra large is 19. So I can't just put in 0.19. Why? Because we're not looking at all of the eggs. It's been narrowed down. So I suppose the first thing I really need to do is go, well, what have I got here? Well, I've got 19 and 23. So I'm really only talking about, well, what is that? 42, is it? Yeah, I'm only talking about 42% of the eggs that the farmer has. I'm not talking about 100%. So I have to be really, really careful with that. So I'm going to put 19 over 42 because it's not 19%. It is 19%, but it's not 19 as in that's not the probability in terms of what's in front of me, because it's only the large and the extra large. So it's really only out of 42% in total, because the rest of them are small and whatever else. So I'm going to do the same then for the next part. So I'm thinking to myself, well, what's left? Well, if I have 19 there, then the unfavorable outcome is that they're not extra large. The extra large, and the not favorable is the go away, sorry. Yeah, is the fact that they're not extra large. Okay, so I'll just sort out my powers. So that's going to be 5. That's going to be 1. That's going to be 6, and that's going to be 0. Now, because it's or one or the other, it's a plus. So when I go to do this on my calculator, I do 6, choose 5, and then I multiply that by my, oh, sorry, I'll do that again. So 6, choose 5, and I multiply that by, now I have 19 over 42 to the power of 5, and I have 23 over 42 to the power of 1. So that's that bit anyway. So now we're going to do it to 3 decimal places. So keep a few decimal places in here for accuracy later. 6, choose 6. So that's obviously 1. So I need to multiply my 19 over 42, or I need to raise it, sorry, to the 6. And then anything to the power 0 is 1. So there's only a little bit to do here. Now, this comes out to be 0.00857, etc. So I'm going to add that on to what I have there, 0.062251. So all in all, it's coming out to be 0.0708, 3 decimal place, 0.071. So 0.071. So in such box, find the probability that that's what the egg is going to weigh. So that's that one done as well.